Welcome to Chem Help ASAP. We're going to talk about making bonds to hydrogen, and these are called sigma bonds. Now, when we talk about bonding, we will almost always talk about energy. So here's our arbitrary energy axis. Of course, hydrogen is going to be part of this picture, but what are we going to bond it to? Well, we're going to bond it to carbon. And just at the bottom left, let's draw up a simple molecule. And let's say this is the molecule we're talking about, and we're looking at this particular CH bond. This is a sigma bond. So we have a carbon, and it's going to bond with an orbital, and it's going to bond to a hydrogen atom. So this hydrogen is going to use a 1s orbital. The carbon in this case is sp hybridized, so it's using an sp atomic orbital. Both of them are going to carry one electron. They're going to mix in the middle. Same picture as always. And we get two new molecular orbitals from our two atomic orbitals. The low energy orbital, we're going to call that our sigma bonding orbital. And the high energy orbital, we're going to call sigma star. That's our anti-bonding orbital. So what do these things look like? Well, for our sigma, in the middle of the screen, the middle column, we're going to think of adding the two atomic orbitals, our sp hybrid plus our 1s orbital. So here is our carbon atom, and this carbon atom is going to bond with the hydrogen using its sp hybrid, and so it's going to interact right next door with the hydrogen, and that's meant to be the hydrogen, and we will also show that. So these are the positive ends of our lobes, and as these come together and interact, we're going to have constructive overlap of this region between. And we'll get some kind of orbital, looks kind of like this. I'm going to ignore the little tail off of the sp hybrid because it just makes the picture messy. Great overlap. Notice that between the two nuclei, we have lots of probability that we're going to see this hydrogen. This is our sigma bonding orbital. Okay, this is great. We've seen similar pictures to this before. How do we look at our sigma star? Well, we're going to look at now at carbon minus hydrogen. So this would be an sp or sp hybrid minus the s. Again, I think that's kind of weird. Let's think of this as adding the negative of the s. So again, we're going to draw our carbon, and here's our sp hybrid. And we're going to interact this with a hydrogen atom. That is now the negative of the hydrogen. So we go to the left, we flip the sign of this hydrogen 1s and we make it unshaded. Now notice we're going to get cancellation of our orbital density here in between. So when we draw this picture, we draw out the final thing, we end up getting something kind of like this. A lot of that interaction in between is gone. Because this part of the orbital gets canceled out, the hydrogen 1s, this part of the hybrid orbital on carbon gets canceled out, and we have nothing in between. So we have a node in between. And this is now our sigma star. This is not a good orbital for electrons because there's very little probability we're going to find that electron in between those two nuclei. So this is a classic picture of both the sigma and sigma star for a CH bond. We could just as easily have done an NH bond or an OH bond using a hybrid orbital off of nitrogen or oxygen. So this is kind of an interchangeable picture that describes these CH bonds or bonds between carbon or second row elements and hydrogen. So this is a quick picture. Again, these pictures are much like the other orbital pictures that we've seen before, but it's just a quick representation of what these orbitals look like between second row elements and hydrogen atoms.